Organic chemistry is the study of the compounds of carbon. Usually hydrogen is present as well. Carbon is so important because it forms the very strongest bonds of any element. It always forms 4 bonds, but these can be arranged in either 4 directions or by doubling up 3 directions. It can also form a couple of double bonds and a single and a triple bond. These different arrangements allow for many different geometries, which is important because these compounds are the building blocks of life. One of the things that carbon can do extremely well is form great long chains, one carbon after the other, not 5 or 10 long, but thousands of carbons long. And these chains can have branches as well, again, adding to the variety of structures. We begin with methane, CH4. Add 2 carbons in a row and you have ethane. Propane is 3 carbons in a row. Always there are enough hydrogens to make a total of 4 bonds for each carbon. Butane is 4 carbons in a row, and here I'm just going to stop drawing the hydrogens. And in fact, pentane, hexane, heptane, octane, nonane, and decane, these are the names of the first 10 building blocks of our organic compounds. Unplug a hydrogen and plug in a fluorine, or chlorine, or bromine, or iodine, or even a nitrogen complex, NO2, called nitro. These side groups allow us to build new compounds. For example, 1 carbon with a fluorine plugged in place of a hydrogen is called fluoromethane. 2 carbons is ethane, plug in a chlorine and you get chloroethane. 3 carbons in a row is propane and you get bromopropane, either attached to the end called 1-bromopropane, or the bromine goes in the middle carbon, 2-bromopropane. Here, the addresses of the carbons are part of the name. This is 2-nitro, 4 carbons is butane. Keep going, we get a pentane. If I have a couple of bromines, that's a dibromopentane, located on carbon 2 and 3. 6 carbons long is hexane. 3 fluoros is trifluoro. They are on 1, 2, and on 2 carbons. Numbers for 1 to 2 trifluorohexane. We can also have trinitro. In this case, trinitroheptane. Number in such a way that the first nitro gets the lowest possible number. Here I have 8 carbons in a row, so it's an octane. We have 3 chloros, and we have 2 iodos. We can call it 5,5,6 trichloro, 2,3 diiodo octane in any order, and 1,1,1 tribromo, 8,9 dichloro decane. These all exist. Well, it's possible that carbon itself can be part of a side chain. 1 carbon hanging off a chain is not methane, but methyl. 2 is ethyl. So here we have 4 carbons in a row, making it butane, and a methyl hanging off of carbon 2, 2-methylbutane. Add 1 to, in fact, let's actually keep going with this. Let's make this 6 carbons long. Both examples here. I'm going to add a carbon, hexane and hexane, but there's a difference. The first one has a couple of methyl groups. It is dimethyl on carbons 3 and 4, whereas the first one has an ethyl group. Note the difference. That's it. Thanks.